Have you ever had this experience? You watch a video explaining something, you understand every part of it. The explanation makes perfect sense. And for a moment you feel confident that you've learned something new, but the next day, it's gone. You try to explain the idea again, and suddenly the details feel blurry. The concept that felt clear yesterday now feels strangely distant. This happens to people constantly. You can read a chapter, watch a lecture, or review a lesson and feel like you understand everything. But when you try to recall the information later, very little remains. So what went wrong? Did you misunderstand the material? Did you forget because your memory is weak? Not exactly. In many cases, the problem isn't intelligence or memory capacity. The problem is that learning never actually happened in the first place, and that might sound strange. Because when you were watching or reading the material, it felt like learning was happening. The explanation made sense. You could follow the ideas. You felt familiar with the information. But familiarity is not the same thing as learning. To understand why most learning fails, we need to understand something important about how the brain works. Your brain does not store information simply because you encounter it. Information becomes memory only when specific biological processes occur. Inside the brain, learning happens when patterns of neurons activate together repeatedly. When this happens, the connections between those neurons strengthen. Signals travel more easily. Communication improves. Eventually, the pathway becomes stable. This process is called synaptic plasticity. It is the biological mechanism that allows experience to reshape the brain. But there is a crucial detail many people misunderstand. Neural pathways strengthen only when the brain actively generates the signal, not when the brain simply observes it. This difference explains why many common learning methods fail. When you reread information, watch explanations, or review notes, the brain often processes the material passively. The information moves through the system once, but the brain does not have to generate the signal itself. And when the brain doesn't generate the signal, the neural pathway receives very little strengthening. In other words, the circuit activates temporarily, but it does not change structurally. This is why passive review creates what psychologists call the illusion of learning. The information feels familiar, but familiarity is not memory. The brain recognizes the pattern when it sees it, but recognition is very different from recall. Recognition means the brain can identify information when it appears. Recall means the brain can produce the information independently, and recall is what strengthens memory. When you try to remember something without looking at the answer, the brain must reconstruct the neural pathway itself. It must generate the signal, and that generation process strengthens the circuit. Each time you recall the information, the neural pathway becomes slightly more stable. This is why techniques like retrieval practice are so powerful. Retrieval practice simply means actively recalling information from memory. Instead of reviewing notes, you try to reproduce the information yourself. At first, this process feels difficult. You might struggle to remember details. You might make mistakes. It can even feel like learning is going worse. But in reality, the opposite is happening. The difficulty you feel is the brain strengthening the circuit. Every time the brain reconstructs the pathway, the connection becomes stronger. Over time, the signal travels more efficiently. The memory becomes easier to access. This leads to an important principle in cognitive science. Learning improves when the process is effortful. Psychologists call this desirable difficulty. When something requires mental effort, the brain treats the information as important. That effort increases the likelihood that the neural pathway will stabilize. In contrast, when learning feels too easy, the brain often does very little work. Signals pass through the system briefly, but the pathway does not strengthen. Another powerful factor in learning is spacing. Many people try to learn information by repeating it many times in a short period. For example, reading the same material over and over again in a single study session. This approach can produce temporary familiarity, but it often fails to create durable memory. When learning is spaced out over time, something different happens. Each time you return to the material, the brain must reconstruct the pathway again. The signal must be generated repeatedly. This repeated reconstruction strengthens the circuit. Over time, the pathway becomes more stable and easier to activate. So now we can see a deeper pattern. Learning fails when the brain processes information passively. Learning succeeds when the brain repeatedly activates the neural pathway itself. This explains why many traditional study strategies are surprisingly ineffective. Highlighting text, rereading notes, watching explanations repeatedly. These activities create familiarity, But familiarity does not guarantee that the neural circuit has strengthened. Real learning happens when the brain does the work of reconstructing the idea, explaining the concept, solving problems, recalling information. These activities force the brain to activate the circuit repeatedly, and repeated activation drives plasticity. Understanding this leads to an important shift in perspective. Many people assume learning ability is mostly determined by intelligence. But the brain does not strengthen neural pathways based on intelligence. It strengthens them based on activation. The more often a circuit activates, the stronger it becomes. This means learning is not primarily about talent. It is about how the brain interacts with information. When learning is passive, circuits remain fragile. When learning is active, circuits stabilize. Once you see this, the process becomes much less mysterious. Learning is not magic, it is biology. Signals become pathways. Pathways become circuits. Circuits become knowledge. But this raises an interesting question. If repeated activation strengthens neural circuits, why do some behaviors eventually run automatically? Why do certain actions stop requiring conscious effort? Because eventually, repeated learning transforms into something else. Something the brain can run without deliberate thought. It becomes habit. And in the next video, we're going to explore exactly how that happens, how repeated learning stabilizes into automatic behavior, and why habits can become incredibly powerful once they form. Because understanding how learning works is only the beginning. Understanding how the brain automates behavior is where things become even more interesting. I'll see you there.